The key question is, when are we going to get fusion? It's really been a long time since we've known about fusion. We've known about fusion since 1920, when Sir Arthur Stanley Eddington at the British Association for the Advancement of Science conjectured that that's why the sun shines. I've always been very worried about resource. I don't know about you, but when my mother gave me food, I always sorted the ones I disliked from the ones I liked. And I ate the dislike one first, because the ones you like, you want to save, right? And as a child, you're always worried about resource. And once it was sort of explained to me how fast we were using up the world's resources, I got very upset. About as upset as I did when I realized that the Earth will only last about 5 billion years before it's swallowed by the sun. Big events in my life, a strange child. Energy at the moment is dominated by resource. The countries that make a lot of money out of energy have something underneath them. Coal powered the Industrial Revolution in this country. Oil, gas, sorry. Gas. I'm probably the only person who really enjoys it when Mr. Putin turns off the gas tap, because my budget goes up. We're really dominated now by those things that we're using up faster and faster and faster. And as we try to lift billions of people out of poverty in the third world, in the developing world, we're using energy faster and faster. And those resources are going away. And the way we'll make energy in the future is not from resource. It's really from knowledge. If you look 50 years into the future, the way we probably will be making energy is probably one of these three, with some wind, with some other things, but these are going to be the base load energy drivers. Solar can do it, and we certainly have to develop solar. But we have a lot of knowledge to gain before we can make solar the base load energy supply for the world. Fission. Our government is going to put in 6 new nuclear power stations. They're going to put in 6 new nuclear power stations, and probably more after that. China is building nuclear power stations. Everybody is. Because they know that that's one sure way to do carbon-free energy. But if you wanted to know what the perfect energy source is, the perfect energy source is one that doesn't take up much space, has a virtually inexhaustible supply, is safe, doesn't put any carbon into the atmosphere, doesn't leave any long-lived radioactive waste. It's fusion. But there is a catch. Of course, there's always a catch in these cases. Fusion is very hard to do. We've been trying for 50 years. Okay, what is fusion? Here comes the nuclear physics. And sorry about that, but this is what turns me on. I was a strange child. Nuclear energy comes for a simple reason. The most stable nucleus is iron, right in the middle of the periodic table. It's a medium-sized nucleus. And you want to go towards iron if you want to get energy. So uranium, which is very big, wants to split. But small atoms want to join together, small nuclei want to join together to make bigger ones to go towards iron. And you can get energy out this way. And indeed, that's exactly what stars do. In the middle of stars, you're joining hydrogen together to make helium, and then helium together to make carbon, to make oxygen. All the things that you're made of are made in the middle of stars. But it's a hard process to do because, as you know, the middle of stars is quite hot, almost by definition. And there is one reaction that's probably the easiest fusion reaction to do. It's between 2 isotopes of hydrogen, 2 kinds of hydrogen. Deuterium, which is heavy hydrogen, which you can get from seawater, and tritium, which is super heavy hydrogen. These 2 nuclei, when they're far apart, are charged, and you push them together and they repel. But when you get them close enough, something called the strong force starts to act and pulls them together. So most of the time they repel, you get them closer and closer and closer, and then at some point the strong force grips them together. For a moment they become helium-5, because they've got 5 particles inside them. So that's that process there. Deuterium, tritium goes together, makes helium-5. Helium splits out, and a neutron comes out, and lots of energy comes out. If you can get something to about 150 million degrees, things will be rattling around so fast that every time they collide in just the right configuration, this will happen, and it'll release energy. And that energy is what powers fusion. And it's this reaction that we want to do. There is one trickiness about this reaction. Well, there's a trickiness that you have to make it 150 million degrees, but there's a trickiness about the reaction. Yeah, it's pretty hot. The trickiness about the reaction is that tritium doesn't exist in nature. You have to make it from something else. And you make it from lithium, that reaction at the bottom, that's lithium-6 plus a neutron, will give you more helium plus tritium. And that's the way you make your tritium. But fortunately, if you can do this fusion reaction, you've got a neutron. So you can make that happen. Now, why the hell would we bother to do this? This is basically why we would bother to do it. If you just plot how much fuel we've got left in units of present world consumption, and as you go across there, you see a few tens of years of oil. The blue line, by the way, is the lowest estimate of the existing resources, and the yellow line is the most optimistic estimate. And as you go across there, you will see that we've got a few tens of years and perhaps 100 years of fossil fuels left. And God knows we don't really want to burn all of it because it'll make an awful lot of carbon in the air. And then we get to uranium. And with current reactor technology, we really don't have very much uranium. And we will have to extract uranium from seawater, which is the yellow line, to make conventional nuclear power stations actually do very much for us. Which is a bit shocking because, in fact, our government is relying on that for us to, meet Kyoto and do all those kind of things. To go any further, you would have to have breeder technology. And breeder technology is fast breeders, and that's pretty dangerous. The big thing on the right is the lithium we have in the world. And lithium is in seawater. That's the yellow line. And we have 30 million years worth of fusion fuel in seawater. Everybody can get it. That's why we want to do fusion. Is it cost competitive? We make estimates of what we think it would cost to actually make a fusion power plant. And we get within about the same price as current electricity. So how would we make it? We have to hold something at 150 million degrees. And in fact, we've done this. We hold it with a magnetic field. And inside it, right in the middle of this toroidal shape, donut shape, right in the middle is 150 million degrees. It boils away in the middle at 150 million degrees, and in fact, we can make fusion happen. And just down the road, this is JET. It's the only machine in the world that's actually done fusion. When people say fusion is 30 years away and always will be, I'd say, yeah, but we've actually done it, right? We can do fusion. In the center of this device, we made 16 megawatts of fusion power in 1997, and in 2013, we're going to fire it up again and break all those records. But that's not really fusion power. That's just making some fusion happen. We've got to take that, we've got to make it into a fusion reactor, because we want 30 million years worth of fusion power for the Earth. This is the device we're building. Now, it gets very expensive to do this research. It turns out you can't do fusion on a tabletop despite all that cold fusion nonsense, right? You can't. You have to do it in a very big device. More than half the world's population is involved in building this device in southern France, which is a nice place to put an experiment. 7 nations are involved in building this. It's going to cost us 10 billion, and we'll produce half a gigawatt of fusion power. But that's not electricity yet. We have to get to this. We have to get to a power plant. We have to start putting electricity on the grid, and this very complex technology. And I'd really like it to happen a lot faster than it is. But at the moment, all we can imagine is sometime in the 2030s. I wish this was different. We really need it now. We're going to have a problem with power in the next 5 years in this country, right? So 2030 looks like an infinity away. But we can't abandon it now. We have to push forward, get fusion to happen. I wish we had more money. I wish we had more resources. But this is what we're aiming at. Sometime in the 2030s, real electric power from fusion. Thank you very much.
Traffic is a global epidemic. US traffic is creating 45% of the world's air pollution. In the UK, time wasted in traffic costs $20 billion a year. Would you pay for cleaner air and a faster commute? Stockholm put it to a vote.
I voted for it, yes.
I voted for it.
I vote for it.
We're not old enough to vote.
We had to do something in Stockholm to improve the environment and to get a better flow in the traffic. We put a price on taking your car into the central parts of Stockholm, and we call that congestion charges.
If you start a system like this and it doesn't work on the first day, then you will be in big trouble. It must be perfect from day one.
There are 18 entry gates to the city. Each is equipped with cameras. Pictures are taken of the rear and front license plates. These pictures are sent to a central system that identifies the license plates and makes sure that the right person pays for the right passages.
One of the obstacles we overcame was the OCR, the optical character reading of the license plate. We went out to IBM's global organization and the R&D centers and found a very good software we could use, and we managed to implement it in 2 months' time.
This is the heart of the system where all images and passages are being processed. Over 99% of all pictures are correctly identified.
No, it's nice. This is how it should be all the time.
Behind me you can see the traffic, and the clock is 6 p.m. Before we had the congestion charging, the traffic was queuing up at this time of the day.
Jag tycker det är en bra idé. I think it's a good idea because I think that we should take care of the environment in the city.
The traffic went down with about 22% and the air pollution was about 14% better.
It's a huge international interest from different parts of the world, from the United States, from Latin America, from China, and it's really a pleasure to tell people not what we are planning to do, but what we actually have done in Stockholm.
I voted for it, yes I did. Not my husband, so but I did. I think he is not thinking like me for the future. I'm thinking for the children and the grandchildren.